we're going to use calculus to find the dimensions of a rectangle with the greatest possible area if it is inscribed with its base on the x-axis and its upper corners on the parabola, which we've graphed here, y equals 6 minus x squared. So what we need to do is draw a rectangle whose base is on the x-axis and whose corners touch this curve. Okay, so this dimension here is y. If we want to make our lives easier, this is 0. So I'm going to go x in the positive direction and x in the negative direction. So this dimension is actually 2x. And we know that the area of a rectangle, because you need a formula so you can take the derivative so you can maximize it. So the area of a rectangle is length times width, or let's go width times height, because those are the words they use. And the width of this one is 2x, and the height of this one is y. And this is what we want to maximize. But this has 2 variables, and we would really like our area in one variable. And if we noticed, we can keep the 2x, but right here is an expression for y in terms of x. So we can replace this y. Let's do it this way. We can replace this y with the expression 6 minus x squared. Okay, so now if we distribute that, we get that the area is 12x minus 2x cubed. And that's the thing we want to maximize. This is the area of this rectangle in a single variable x. So if we want to maximize it, now we have to take the derivative. So we do the derivative of the area with respect to x. And this gives us 12 from the 12x term. And this gives us 6x squared from that last term. Now, remember, to find the maximum, we need to take the derivative and set it equal to 0. So I'm going to take 12 minus 6x squared and set it equal to 0 and see what x accomplishes that. So first, I'm going to factor out a 6, and I get 2 minus x squared equals 0. And then I'm going to divide everything by 6, which is the great thing about 0, is that 0 stays the same. And now this side is just 2 minus x squared equals 0. So whatever x we can find that solves this will give us the maximum, 2 of them, 2x, 2 of those x's, and y will give us the maximum area dimensions. So I'm going to put x on the other side, and I'm going to take the square root of both sides and get that x is plus and minus the square root of 2. So that means that this spot right here must be the positive square root of 2, and that this spot right here must be the negative square root of 2. So altogether, this width is 2 times x is the square root of 2. So there's one of your answers. That's the width. And then to find the height, we already know what y is. It is 6 minus x squared. So that's the square root of 2 squared. So this is 6 minus 2. And it turns out that the height, or y, that's a minus, is 4. Or do they have units? No. So those are your answers. Width, width, height. And that's how you do it with calculus. Thank you.